Okay, in this video, we're going to look at absolute value inequalities. If you haven't looked at the video for absolute value equations or compound inequalities, I recommend you go back and review those first because we're going to use those ideas in this video. Okay, so let's look at a basic absolute value inequality. So we've got something like x is less than or equal to 5. Okay, so remember the definition of absolute value is that it's the distance from 0. Okay, so absolute value is telling you its distance from 0. So if we've got the absolute value of something is less than 5, then it means it's all the numbers that are within 5 of 0. So here's 0, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 this way as well. So that means that we have all of the numbers that are less than or equal to a distance of 5. And since we're less than or equal to, that's going to give us square brackets. Okay, so that interval is going to be -5 to +5, and we can write it as one compound inequality, -5 to x to +5. Okay, so this is saying that all of these numbers have to be a distance that is at most 5 away, so between 5 and -5. All right, now that's the less than version. Let's say we have greater than. Let's say we have absolute value of x greater than 3. Okay, so we've got 0, 1, 2, 3, 1, 2, 3. And this time we want our distances to be more than 3. So we can't be less than 3. We can't be close to 0. We've got to be far away from 0. We want to be more than 3. So these are all the numbers that are more than 3 that direction. These are all the numbers that are more than 3 in that direction. And this time we're not included, so it's going to be a round bracket. Okay, so what do I end up with for this inequality? I've got, if you want to write it as an interval, we've got -infinity to -3, not included, and 3 to infinity, not included. And we can also write it as two separate inequalities, x greater than 3 for the positive one, and x less than, just less than, -3 for the negative version. Okay, so if you can remember this idea about distance, okay, being closer than this number or greater than this number, that'll help you solve them because this tells you what to do for the general rule. Okay, so the general rule for less than, that's the first one, is if we have some expression in x, this is going to be an expression in x now, and we have the absolute value less than some number. Okay, we can solve this by making a two-sided inequality like this. So it's going to be between -a, that expression is going to be between -a and +a. Okay, strictly less than if the original problem is, or less than or equal to if the original problem is. Okay, so if it's less than, it's got to be between -a and +a, just like we saw here. So let's look at an example of that. Let's say we've got x minus 4 plus 5 less than or equal to 12. Okay, so we saw one like this before. We need to be in this form to do anything. Okay, it's got to be absolute value and a number. Right now we've got this 5 sitting here. It's messing up our format and everything, so we need to get this to be absolute value over here. So we need to move this 5 to start. Okay, so now we've got x minus 4 on the left, and on the right we've got 7. Okay, so now we look like the original idea here, or our format here. We've got something, some expression is less than or equal to 7. So that means that this thing right here has got to be between 7 and -7. So we can write this as being between 7 and -7. Okay, so see this expression in x? It's going to go here between the negative number and the positive number, which is the same idea that we saw up here. It's going to be close. It's going to be like a sandwich. Okay, now I'm kind of running out of space here. Let me see if I can slide this up just a smidge. Okay, so now we're going to solve this two-sided inequality like we did before. We want to get x by itself, so we're going to add 4 to both sides. Add 4 to both sides. Add 4. Okay, so we add 4 to all 3 pieces. And we're going to get a -3 on the left, x in the middle, and then 11 on the right. So this tells us that x has to be between -3 and 11 for this inequality to work. Okay, we can also write that on a number line. There's -3, there's 11. We're going to be greater than -3, -3 is included, and we're going to be less than 11, and our values are going to be between the two. Okay, just like we see here. Okay, so that's the case for a less than. A less than. You can put it together between the positive and negative and then solve. Okay, they might not, they match when you start, but they're not going to match at the end. Okay, so that is the less than case. All right, greater than case. This is a completely different problem because now we want to be greater, we want to be farther away than that number. So for this one, we've got absolute value. Okay, so some expression in x is going to be greater than a. And this example shows us what we're going to do. If we want to be greater than a number, that means we're going to be greater than the positive and or less than the negative. Okay, so we have to get both of those pieces because we've got to be farther away. We need the two ends. So greater than the positive, less than the negative. So you get this greater than the positive, and you get this less than the negative. Okay, so for the greater than case, you're going to get two inequalities because you got to get two pieces. You cannot put these together in one inequality like the first case. All right, so okay, so let's try one of these. Let's say we've got 2x minus 1 greater than 9. Okay, so the first thing you've got to notice, is it greater than or less than? Because it's two different cases. This is greater than. So I know that I've got absolute value greater than 9, so I need this thing in here to be bigger than 9, or I need this thing in here to be less than -9. Those are our two versions. So 2x minus 1 greater than 9, or 2x minus 1 less than -9. Okay, again, that gives us our two end pieces out here. We've got to be far away from the middle. Okay, and then we solve for x to decide what x values will work for this. So we're going to add 1 to both sides, and we're going to divide by 2. So that's going to give us x greater than 5 for that piece. And then we're going to do the same thing over here, add 1 to both sides, and divide by 2. And we're going to get x less than -4. Okay, so let's look at this on a number line. So here's -4, here's +5. So we're going to get less than -4, and that's not included, so that's a round bracket. And we're going to get greater than 5. That's not included as well, so that's a round bracket. Okay, so less than is going to be like a sandwich, it's going to be in the middle. Greater than is going to give you the two end pieces, and you solve to get those numbers. So the interval reading from left to right is going to be -infinity to -4, never included at infinity, also not included at 4. And we're also going to have 5 to infinity, not included for either as well. Okay, so you've got to decide when you look at these, is it the positive case, or sorry, is it the less than case, or is it the greater than case? Because you're going to do two different things for them. Okay, let's try a couple more. Let's say that we have 2x plus 3, absolute value, less than 15. Okay, so this one's less than. Less than means close, so that means that we've got to be between 15 and -15. Okay, so whatever's inside here has got to be between 15 and negative 15 because our distance has to be less than 15. So less than, okay, so less than we can write as one inequality. All right, so we've got to be between negative 15 and positive 15. Okay, so now we can solve this. We want to get x by itself, so we're going to subtract 3 from each piece. That's going to give us negative 18, 2x, and 12. And then we want to get x by itself, so we need to divide by 2. So we do that to all 3 pieces. And we're going to get negative 9 less than x less than 6. Okay, so we have all the numbers from negative 9 to positive 6 not included. So our number line is going to look like that. And our interval is going to go from negative 9 to positive 6 not included. Okay, so that one's a less than. Less than is between the two values. All right, let's try one more. Let's say we've got 3x minus 1 greater than or equal to 14. Okay, now this one is greater than. That means we've got to be farther away than 14. So picture the two ends of the number line. So that gives us two different cases. So we need 3x minus 1 greater than 14. That's the positive case. Okay, so we've got to be past 14 on the positive side. Or we've got to have 3x minus 1 less than negative 14. That gives us the negative tail. Okay, so positive tail, negative tail. So we've got to be bigger than 14 or less than negative 14. Okay, now let's solve this. So we're going to add 1 to both sides and get 15, and then we're going to do the opposite. So we're going to divide by 3, and we're going to get x greater than or equal to 5. Okay, we're going to do similar over here. We're going to add 1 to both sides. We're going to get 3x less than negative 13. Divide by 3, and we get a fraction for this one, x less than or equal to negative 13 thirds. Okay, putting it on the number line. So we've got negative 13 thirds and positive 5. We want to be less than negative 13 thirds. Okay, that gives us the left side, and that's included. And we want to be greater than 5. So that's going to be the right-hand side, also included. Okay, so again, we see the numbers change, but we see the same kind of shape. If it's less than, it'll be between. If it's greater than, it'll be on the outsides. So our interval for this one, going from left to right, always important. Negative infinity to negative 13 over 3, not included at infinity, is included at negative 13 over 3. And then we also have 5 to infinity, included at 5, never included at infinity. Okay, now please note here, you cannot put these two inequalities together. Two inequalities, two separate pieces of the number line, two separate intervals. Okay, they cannot be mashed together. This one can. One inequality, one piece on the number line, one interval. Okay, so that's an important distinction between the less than and the greater than. Okay.